So calculate the percent mass composition of all the elements in magnesium sulfate and display the answer in 3 significant figures. Okay, so you guys are ready? So what is the chemical formula for magnesium sulfate?
MgSO4.
MgSO4, that is correct. How many magnesium?
One?
Just one. Yeah.
Hold on. Never mind. Okay, 1, that's right. Okay, and then let's go to P table. And magnesium weighs
Where is it? 24.305.
And of course, since there's only 1, we're going to multiply that times 1. Okay, and then how many sulfur? How many sulfurs?
One?
Okay, we have 1 sulfur. And sulfur weighs
32.06
2.
times 1. 32.06. And oxygen is 4.
Okay, so we got 4 oxygens.
15.999 times 4.
Okay,
I don't have my calculator. Oh my gosh. 63.996.
okay, so we add them all together.
It's 120.361.
Okay. So 120.361. And we know that's going to be grams per.
Mole.
Okay. Okay, so now that we know that, let's go back to the problem. We have all those goodies. And so what was the oxygen again? It was what? 60 point, no,
Oh,
60,
63.996.
okay, perfect. Okay, so let's go back to the problem. Okay, so if we go back to the problem and it says all of the elements, right? So we want the percent mass composition. So what is the definition of percent mass composition?
What is that?
Isn't it like what percent of each element, like the percent of its mass of each
Other
element?
mass.
Of
Yeah.
each element, that's right. So we want of the specific mass, so we're going to say like A over total. Of compound. And you're right, it's mass. Put that in there. Times 100. Okay, so in this case, we're going to do magnesium. So we have
So it's like the 24.305 times 100? Or no?
yep. So it's going to be, like you said, 24.305 times, you're right, 100, but it's going to be divided by
Oh, divided by what? I can't remember.
120. Remember?
Oh, the total. Okay.
Okay, so we do that math. Okay, so and that's for magnesium. Then we need to do the same thing for sulfur. It will be 32.06 times 100 over 120.361.
It's 26.6, I think.
26.6. That's for sulfur. And then for oxygen, we can go ahead and use that number up there, or we could just subtract it by a total of 100%, both of these by 100. Both of those would give me the answer. So we can do it the way that we've done everything else.
Times 100.
Do we have to do each element like individually, or could we do like sulfate like all in one?
No, you're gonna have to do each one individually because that's what it's asking you.
Yeah, it says
Okay, okay.
of all the elements. I was thinking the same thing earlier.
Yeah, and that's the secret to a lot of the questions. You gotta think about what they're asking you.
Yes.
Usually, it's funny because like I look at some of the work that you guys have done, and usually what it is that you guys will you go through the process, you do the calculations, and then but you're not reading the full question, right? And so it'll be asking you for something else. You've done all the hard work, but it'll be asking you for something else.
Yeah, one of the questions it was asking for, oh, like the coefficient. I think it's like just the coefficient in front of like for barium, but I was adding all the coefficients and I was on the tutoring with Angelique and I was like, I can't get this question. I was like, it's not in the answer, like my answer is not in the selection, but it's the right answer. And then she looked, she goes, oh, look, it's just asking for the coefficient for barium, not for the sum. And I was like, oh my gosh. I was
Yep,
like,
and
in my
it's
head.
tricky. Yeah.
Yeah.
And what it is trying to get you guys get in the habit of reading the instructions because when we're in the real world, you're going to have instructions to read, and usually there's nobody's going to tell you, okay, you need to do this, you know.
Yeah, that's true. Yeah.
It's so funny. Every day that I teach, I'm starting to sound more and more like Mr. Grant in the real world.
In the real world.
I don't know if you guys have Mr. Grant.
I
He's
did.
good. Yeah, yeah. He's hard, but I think he's a good instructor.
He is.
Uh,
Yeah. I had him for speech.
yeah. Okay. So 53.2%. Okay.
Yeah.
Questions?
No.
Concerns? Okay. So let's see what time we got. Okay, we got 8 minutes. I think we could squeeze at least part of one in, right?
Hmm.
From
Hmm.
each. Okay. Okay, everybody got that?
And it's all these odds add up to 100%, right?
Yep, that's
Or
right. It should add up to 100%. If you do the math, doesn't that add up to 100?
yeah.
Yeah, good. Okay. So, okay, so I'm gonna move it up a little bit, and so it may take up other spaces, but I'll leave it on there for those who came in a little bit late. Okay. Calcium nitrate solution. Cobalt 2 fluoride. I'm sorry, calcium nitrate solution and cobalt 2 fluoride react to form a precipitate. Identify the chemical reaction. Predict the chemical reaction. Write a balanced chemical equation. Okay, identify the type of chemical reaction, predict the chemical reaction, and write a balanced chemical equation. Okay, so first off, what is the chemical formula for calcium nitrate?
So we need 1 calcium and 2 nitrates.
Okay, so we have 1 calcium.
And then our parentheses for the nitrate.
Okay,
And then the subscript on the right, bottom right.
so we get that from our polyatomic ion table, and we got the subscript on the right.
Yeah.
Perfect. Okay. Then we have cobalt 2 fluoride. Well, first off, the first thing that we know that these are our reactants, right? Because it says they're reacting. So
Yeah.
reactants react.
Hmm.
Okay.
And the cobalt's already a 2 charge, so we just need 1 cobalt and 2 fluoride.
Okay. So since we know that this is Roman numeral 2, that means our cobalt is going to be a +2 charge. That's right.
Mhm.
And then we're going to have 2 fluoride. Okay. Now it says solutions. What does that mean? Is that going to be a solid, liquid, gas, or aqueous?
Aqueous.
Aqueous. And then that's going to yield. Now, this is the part that we've got to think about it. What type of reaction is this?
I think it's I forgot what the word is, like
The
double,
double displacement or replacement?
Yeah.
Double, right?
because it's 1
That's
metal
right.
and 1 non-metal on each.
Double displacement. Okay, so now the next part is to try to figure out whether or not we're going to have a product, right? So the way that we're going to do that is we're going to go to our chemical, see if I have it open. Okay, so we know that we have cobalt 2 fluoride. So we want to go over to fluoride. So that guy's nearly insoluble already. Okay, so what does nearly insoluble mean?
Is it like it's gonna stay a solid?
It's almost going to stay a solid. Under the right conditions, if we dilute it enough, we can make it into an aqueous solution. So if we assume that it's already a solution, somebody's already done that work to make it aqueous. Okay. So then if I have calcium nitrate, let's see. Let me get my pen so I can explain this. So we know that calcium is going to be hooking up with who potential?
Fluorine.
Fluorine. And then the cobalt is going to be hooking up with whom?
The nitrate.
The nitrate. Okay, and so calcium fluoride is also, I believe, nearly insoluble. Slightly soluble. So slightly soluble. Yeah, this is not working out very well. Hold on. You guys see my page there?
No.
There we go. Calcium, slightly soluble. Okay, so we know that in that case, if they're coming together, then it would form a precipitate, right?
Mhm.
So we have Ca F2. And since it's a precipitant, we're going to put a solid. Plus, the other one would be, you said, cobalt nitrate, cobalt 2 nitrate. That's right. Okay. And then that's going to be aqueous, because we know that nitrates, all nitrates, we look over here, they're always going to be soluble. You guys see that? Okay. So now we need to balance our chemical equations. So let's go to a sheet that we can actually see what we're doing. Go back to that survey. Okay. Okay, and then I'm going to erase all of the matching up there.
Wait, why is cobalt nitrate aqueous again?
Because Nate, when it comes together, it's soluble. Like if you have cobalt 2 nitrate coming together, it's anything with nitrate is always going to be soluble. So it's always going to dissolve in solution.
Okay.
Okay. Yeah. Okay. So we have calcium F2 and CO NO3 parentheses 2. Okay. So is it balanced?
Yeah, it looks balanced.
Balanced.
Yeah.
Okay. So that's it. Not too difficult. What's the hardest part?
Doing the aqueous and the solids,
Yeah.
Yeah.
going through that packet.
The products, yeah.
Mm-hmm.
And remembering to go through that packet. So like if it were me,
Yes.
since you guys get your cheat sheet, so that would be one thing to look at solubility table, that I would write down. You guys see the table,
Yes.
solubility table?
Yeah.
Yeah, we can see it.
Okay, question number 3. You have 85.0 grams of barium chloride pentahydrate. Determine the number of moles and molecules of barium chloride pentahydrate.
Where are we at? Oh, okay. 85.
Okay, what do you guys, oops, damn it. Sorry. Okay, we're good now. Okay, so 85.0 grams of barium chloride pentahydrate. Okay, so what are we going to do?
Chemical formula.
Chemical formula. Okay, good idea. So what is the chemical formula of barium chloride?
Um,
BaCl2.
BaCl2.
Thank you.
Because we know that barium, if we look on our periodic table, I forgot my 2. Put that 2 in.
Pentahydrate. 5.
Big old dot. And you said 5. 5 what?
Is it H2O?
H2O.
Oh.
Okay. As we were saying, the barium, we know it's group 2 metal right there. So we know that it's going to be, when it forms an ionic compound, it's going to be a +2 charge. And we know that chlorine in group 17, which is 1 away from that noble gas, that means it's going to be a -1. That's right. So since this guy is 2 away, okay. So then when they come together, they have to balance out to 0. And then we know that when we talk about hydrates, that's water. Okay. And let's go. Okay. So we have barium 2. Okay. So now it's all we got to do is, again, go to the periodic table, and we need to figure out our masses, right? Gave myself away. What's next? I got ahead of myself.
Um,
The hypoarsenous. Oh wait, no.
Let's go back to what it says. It says barium chloride pentahydrate. So we got the 5 waters, and it says determine. Oh, you're getting ahead of the game there, Julian. You're looking at the next question. It says determine the number of moles and molecules for barium chloride pentahydrate. So how would I determine the number of moles? What do I need to figure out first?
The mass of
Molar mass.
The molar mass, that's right, of our barium
Chloride pentahydrate.
chloride pentahydrate. Yeah. So how many bariums do we have?
1.
1 barium. And then how much does barium weighs? Pull up our periodic table. So
137.33.
okay, 137.33. And there's only 1 of them, so times 1. Okay, how many chlorides?
2
2 chlorides.
and 35.45.
And that's times 2. That's going to equal
70.9.
okay. And how many hydrogens?
5. Oh no, 10.
We got 10 hydrogens. So, and that's
1.
1.
The door, Mom. We'll go open the door. Oh yeah. I hear you.
Times 10. So that's going to be what? 10.08. Okay. And oxygens? How many
there's 5
oxygens?
oxygens,
5.
and that's 74.995.
So 74.995. And we get that because we have 5 times
16. Or 15.999.
okay. Okay. So then we're going to add them all up.
That should be 283.225.
You said 283.
0.225.
Okay. Do you guys agree with him?
I hope so.
Okay. Okay, so now we have the molar mass. And we know that we're starting off with, we'll go back to the question. I wish I could put screen and screen. I think it's possible. Okay, so we're going to start off with our given, which is going to be 85.80 grams of barium, or barium chloride. Okay. And then what's next? Oh, we did this work. Now how are we going to use it?
We're going to put G under and then mole on top.
Okay, so we're going to put our grams on the bottom. And then 1 mole on top. Okay, so our barium chloride, pentahydrate.
Oh,
You can't be yawning already. Still
I'm
early.
sorry. I went to sleep like at 4 in the morning.
Hey, that sounds like me.
That's the time you woke up, huh?
No, I went to bed. I went to bed about 4 in the morning.
Oh.
I was planning to get up at 5, get an hour of sleep.
Uh-huh.
Ended up, I didn't get up till well, I got up late. I got up at 6:45. That's because my sister called me. She's like, "Hey,
Oh.
do you want your cookies or what?"
Eh.
Okay. So if we do that math, what are you going to end up with our moles?
A long list of numbers, but we're gonna keep our separate three, so hopefully 0.303.
Okay.
I know we should already know this by now, but can you remind me like what mole means again?
Mole
Yeah.
represents quantity, right? It's going to give us so it means like a group, like a dozen. So like if I have a dozen of donuts, how many donuts do I have?
12.
12, right? So we know that 12 always means a dozen. Well, a mole always means that you have
0.022 times 10.
that's right, 6.022 times 10 to the 23rd of whatever you're talking about, right? And so
Yeah.
a lot of times when you say, I'm going to go get a dozen of donuts, right? People know you're going to get a box of donuts that have 12 donuts in, right? So that's the way it is. So it's the same concept as a dozen. Only thing, it's a much bigger number.
Isn't that the Avogadro number, right?
Yeah.
That's right. Avogadro's number is the 6.0022. But we use a mole because, like, when we're working with stuff in the lab, we use so much of it, it's dumb for us to sit there and say that, well, I have 12.2500 times 10 to the 25th of potassium, you know. It's a lot easier to say that we have so many moles, you know. So you said 1 point, sorry, Mark, you said 0.1.
I said 0.303. I think that's what I got.
Make sure.
Oh, yeah.
85.0
That's what I got too.
divided by 283.22. Okay.
But do we need 4 sig figs? Or is it?
Yes, you're right. We're gonna need 4 sig figs because that's what we're starting off with.
Oops.
And so that would be our moles. By the way, Josh, that was a good question because a lot of times people will mistake moles for molecules, right? They're
Mm-hmm.
two different things. And it's really easy. That's kind of why I gave you guys this problem because 9 times out of 10, people make that mistake.
Yeah, you really have to like remember like the terminology and all that.
Yeah, that's right. Okay, so now that we have our moles, can we figure out our molecules? What do you guys think we're going to use?
Avogadro's number.
Avogadro's number. That's right. So we're going to start off with our moles. Okay, so I'm going to put Avogadro's number on top. Times 10 to the 23rd molecules. And then our 1 mole on the bottom. Okay. What do you guys get?
1.981
Okay.
times 10 to the
Let's
23rd.
put it somewhere. Oops, I sure did. So I got 1.824 times 10 to the 23rd.
Oh, wait, I forgot to add a 0 after the 3 on the moles.
Uh.
Okay.
Okay. So if we're given mass, we're going to use molar mass. And if we're given moles and they want molecules, then we want to use Avogadro's number. Okay, so now let's do some nomenclature. Ooh, you guys excited?
Yeah.
You got to control that excitement. Okay, so the first one, it's hypoarrhenius acid. I'm sorry, what's that?
Arsenious.
Sorry, arsenious, yes. Putting an H in there. Arsenious acid.
That's arsenic. But
Okay, so that's right. It's going to be arsenic. Okay, so arsenic chemical formula is, or chemical symbol for arsenic?
is it AS or
Okay.
AR?
AS. Okay, so it's AS.
Yeah.
Okay, so if we look at our periodic table, what is in the same group as the AS?
Phosphorus and
Phosphorus.
ammonia.
So so if we go to, we know phosphorus, we're familiar with phosphorus. And so phosphorus, phosphate would be what?
Oh, I need my table.
Okay.
Phosphate.
What is phosphate? Chemical formula for phosphate?
PO4 with a 3 negative charge.
PO4 with a 3 negative charge. Okay. So we have, if we look at our question. Okay, so we have hypoarrhenius. So it's, take a look at this. This is hypoarrhenius. We know that arsenic is going to be in the same group as PO4, as the phosphate. So if we have ASO4, we know that that should have a 3 minus charge, and that would be called arsenic, right? Okay, so if I want to go down to ASO4, ASO3, yeah. 3 minus, then that's going to be called arsenite. And then if I want to go down further to
Two.
AsO2, yeah, 3 minus, then I'm going to call that hypo.
Oh,
Hypoarsenite. And then I can use my little cheat sheet, those little, what is it called? Mnemonics? I think they're called mnemonics. I ate organic apples despite them being poisonous. I think I have that on this sheet.
Yeah.
yeah.
Okay. So I ate. Okay, so what does ite match up with?
OUS.
OUS. Okay, so when I know it's an acid, it has to be OUS. What makes an acid at the level that we're?
There's an
Hydrogen.
H in the
Okay,
beginning.
we need that H. Okay, so let's go put that H there. So and how many H's will we need to balance it out?
2.
3.
I'm going to need 3 because each H represents a plus. So I'll need H3, AS.
Oh yeah, I could see it. I couldn't see it.
Yep. Okay. And then we just throw in that AQ to remind me that this happens in an aqueous environment.
Okay.
That hydrogen acts like an ion in an aqueous environment. Okay. So let's go to the tab that we can actually see it. Okay. So that would be the name for the first one. Go ahead and put that over here for our A. Okay, so what are we going to do for B? What is B?
Aren't they all just need to be numbered?
We just need to number them. So tetra means what?
3. No, 4.
4. So our phosphorus has 4, so we're going to go P subscript 4.
4. 2.
Bromine to be
BR2.
BR2. Yeah.
R2.
And F9. Or FL.
That's right. F9.
F9.
Yep. And F9. Okay. Now, again, this is one of the things that students will do a lot. They will put the numbers in front, which we know is wrong because those are coefficients, right? So that would be this is the correct answer. Yep. Good job. Okay. Number C.
Iron is what?
or
Fe?
iron's gonna be a charge 4.
Okay.
Hmm.
So iron is going to be a charge 4. What is the symbol for iron?
Fe.
Fe. So we know that now it's going to have a +4 charge. Okay. And then sulfate. I mean sulfite.
Sulfite.
So
SO3 with a -2 charge.
SO3 with a -2 charge.
So we
We
need
can
a
find out.
parentheses.
That's right. So we're going to need parentheses. How many?
Just
Fe.
just
Only
2.
2.
E2.
That's right. Fe SO3 subscript 2.
And then we need our dot for the 5H2O.
And we're going to need a dot for the 5H2O. Okay. And that's it. Oops. Okay, so that would be our C. This out of the way. Okay, what about D?
It would be similar to B, but we just have to put the G for gas. So we're gonna
Okay.
have to put H2.
SO2.
And the
My S looks like a 5. I apologize.
Mhm.
And a G for gas. Okay. And then the next one.
CA. Let me see if that's no mate.
Mhm.
Simple for that.
No. It's
Or
chromate.
somebody said CR what? CR2? Is that what I heard?
No, I forgot the symbol for thing for
CRO.
dichromate.
CRO.
What's
CRO? Are you
Is
sure?
it? No. No.
CRO7.
That's right. CR07. That is correct.
There you go, Justine.
Thank you.
And we know that that has what charge?
-2.
Two.
-2. Okay.
Let me remember what calcium. I think calcium is a 1.
Are you sure?
Double check. No, it's a 2.
A 2.
So it's already balanced.
Okay, it's already balanced. All I have to do is put it together. So let's go do that. So we'll get rid of the charges. And then we'll just pull it together. And that's the other thing that a lot of students do. They leave the charges. So remember, it always has to balance at the end. Okay. Is that good? You guys are good?
Yes.
Okay. So now let's go through some multiple guesses. Now that we get the thought process. Ready for some multiple guesses?
Maybe.
Okay. Okay, let's clear these. Did everybody get everything down?
Yes.
Mm-hmm.
Anybody need a little extra time? Okay, I'll clear. Okay. Considering the hypothetical reaction, A plus B yields AB2. If 2 moles of A and 5 moles of B are placed in a container and allowed to react, how many moles of AB will be formed? And how many moles of which reactants will remain unreacted? Okay. So we have a balanced chemical equation. Do I need to make this bigger, don't I? Because I can hardly see it.
Yeah, that's a little bit.
Oh, yeah, like that.
That's better. Okay.
Uh-huh.
So we know that we have 2 moles of A and 5 moles of B. So let's go ahead and start off with that. We're going to start off with our 2 moles. So we want to look at that ratio. What is the coefficient in front of A that we have?
1.
It's 1, right? And
Yeah.
then if we looked at how much of AB we're going to have, that we're going to make, what would that be?
1.
1. So we're going to use a 1-to-1 ratio. So for every 1 mole of AB, we're going to need 1 mole of A. Sorry, AB2, sorry. So then we can only make, if we have 2 moles starting out, we can only make 2 moles of AB, 2. Now, if I have 5 moles of B, what is the ratio between B and AB?
There's 2 Bs.
Okay.
Mhm.
So for every
2 more.
1 mole of our AB, we're going to need 2 Bs. Okay. So then that is 2.5.
Mm.
Okay. Now, if we look at this, we compare how much if we started off with A to how much if we started off with B. Well, we know that we're limited. One is limiting.
Mhm.
And you know that by the one that's going to give you the lowest value. So I think I talked to you guys about cheese sandwiches. Maybe not.
No.
So the easiest way of thinking about this is if, let's say we're doing cheese sandwiches, making cheese sandwiches for a group of friends. I have 10 friends that come over. And I have 20 slices of bread and 8 slices of cheese. Now, for a cheese sandwich, our cheese sandwiches are simple. It's just bread and cheese. That's all we need. 2 slices of bread, 2 bread, and 1 cheese.
So
That's
then
going to
wouldn't
be
we
our
have 2 moles with the 1 unreacting B?
set. Why do we have 2 moles?
No, because wouldn't it be like because like the whole cheese
Oh
thing,
yeah.
it would be
Yeah.
like with like we just have like extra bread on the side, not doing anything.
Yeah, you have extra bread, but that's
Yeah.
the way it works, right? Sometimes you have extra of one thing. You can only make as much as you have, right? Does that make
Okay.
sense?
Yeah.
Yeah. Okay. So if you don't have any more, you're screwed, right? That's all you can make. So we can only have eight sandwiches, right? Because our cheese is limited. Does that make sense?
Yep.
Okay. So in this case, it's the same thing that's happening. Our A is limiting, right? So that means that our B is in excess. Okay. So we need to figure out how much B we would actually use and figure out how much would be left over, right? So the first thing is that we can only make 2 moles. So we can get rid of this one. We can get rid of this one. We can get rid of this one. So it's either one, the A or B, right? So we figure that out, but we know that we can make 2 moles of AB. So we can kind of use that to figure out how much B we would actually use. So if we go 2 moles of our AB, 2, that's gonna make, we're looking at the ratios, it's gonna be B to AB in this case. So then for every 1 mole of AB, we get 2 moles of B based upon the ratio on our chemical equation. So then we end up with 4 moles of B is what we're going to need. So how many do we have?
5.
We have 5. So we're going to go 5 minus
Minus
4.
4.
Is 1 unreactant.
That's right. So we're going to have 1 that's going to be unreactive.
Mm.
Okay.
Okay.
So you may want to write that down. I always like using the cheese theory because we understand cheese sandwiches better than we understand some of the chemicals sometimes, and sometimes those chemicals freak us out.
Mm-hmm.
How did you get the conversion factor of 1 mole AB and 1 mole A?
It's right here in our chemical equation. So after you get a balanced chemical equation, you're always going to use those ratios. That sets the standard of how much you're going to use. Does that make sense?
Kind of.
Okay, we'll do another. Don't worry. I have more in here, I promise you. So let me erase. So this process is called stoichiometry. Come on. Okay. So propane is burnt as fuel in heating homes. Write a balanced chemical equation. What is the coefficient for CO2? Okay. So what is the chemical formula for propane?
C3H8.
What is it reacting with?
O2,
O2, that's right.
and then the products are always like water and carbon, I think.
Was it single?
Water and
Carbon dioxide.
carbon dioxide. So here, this is one of the things that we can also take advantage of. Sometimes questions will give us that answer that we're missing, right?
Mm-hmm.
Okay, is it balanced?
No, the carbons are not balanced.
Okay, so we know the carbons are
And the
not
hydrogen.
balanced. Okay, how many carbons do we have on our reactant side?
3.
3. On our product side?
1.
One.
Okay. How many hydrogens do we have on our reactant side?
8.
And on our product side,
2.
2.
how many oxygens do I have on my reactant side?
2.
And on my product side,
3.
is it balanced?
Oh,
No.
No. Okay, what can I do to balance it?
we can put a 3 on the right on the CO2.
Okay. Okay, so then that gives me 3.
And then 6 oxygen.
6.
So
Wait.
yeah, 6. Oh, sorry.
On the
6
back.
oxygen. Sorry. My brain wasn't working. Okay.
Wait, no, that's 7. I wrote it wrong because I forgot the other H2O.
So 7 oxygens.
Oh, yeah, that's right.
Okay.
I was looking at my paper then on screen.
Okay, so we got 7 oxygens. Okay, is that balanced?
No.
No. What do I need to do?
7 and multiply everything by 2.
Are we going to do that yet? How many hydrogens do we
No.
have?
We
Wouldn't
can put
it
a
be
4
easier to
there.
work on the
4.
hydrogen?
Yeah.
Okay. Well,
Equals.
we got ahead of the game there for a minute. So that gives me a
I'm
total of,
sorry.
oh, that's all right. That's a total of 8 hydrogens.
And now 11 oxygen. Wait, let me do that again. No 10.
So 3 times 2 is what?
Okay.
6.
6 and
Plus
then
4.
4 times 1 is
10.
10.
10. So we got a total of 10. Okay.
And now. Okay.
So what do I
Now we
need to
do
put
a
in front of
5 on the left for the O2.
Oh, yeah, and that's 10.
See, y'all were just expecting it to be really hard and making it
Yeah,
harder
and
than it
it's a
was.
lot simpler.
Yep. Okay. So then what is the coefficient that we have in front of CO2?
It's 3.
3.
3. Oh, that's all I was asking for.
Yep.
So we
Okay.
could have stopped right there.
That's what
Okay.
I was thinking.
Okay, you guys ready for the next part?
Yes.
Okay, let's see. Let's erase this. Okay, question number 3. The net ionic equation for the following are, let's see, wait. In the net ionic equation for the following, what are the spectator ions? Let's talk about this real quick. I'm going to give you guys a crash course. Anytime, and here's like legit. Quick answer. Anytime you see AQ here, AQ here, AQ here, AQ here. So where you have AQs on both sides, that should tell you immediately that everything is spectators and you will not have a reaction.
It would
Okay?
have to be a solid.
You have to have a solid, liquid, or a gas. Okay? So I'll say that again. Anytime that you see AQ on both sides, they're all AQs on both sides of the equations. That means that everything is going to be a spectator. Okay? Okay, there has to be either a solid, liquid, or gas. So something either has to become a gas or become a precipitate, which is a solid, or becomes a liquid. Okay? So, quick way, you don't have to do anything in that case. Now, if you had to do something, what you would do is just break these into their ions, and then you figure out what's left over, what formed a solid. So let me give you an example. So if I have silver nitrate reacting with sodium chloride, and they're AQ over here and AQ over here. Okay, and then we get to the other side of the reaction. Silver, when it gets to chloride, it forms a solid. We can confirm that with our table, our solubility table, plus
Let me see. Sodium, and then
NO3.
let me check the charge on NO3.
Is it negative? No.
Yeah.
okay. And then that's going to be an AQ, because anything with nitrates are always going to be soluble. Okay.
Mhm.
So then we just have to get AG plus CO and the arrow AgCO.
Mhm.
We have to put the aqueous for each little one on the left.
Okay. So like you're saying, these guys are going to break up into their ionic compartments, right? Like you said. So they're going to be Ag plus, and then you're going to have a big plus. Let me do this right. You get carried away. AgAQ plus NO3AQ minus
Oh my.
plus Na plus AQ plus Cl minus AQ
Yield.
And that's going to yield, that's right, Ag, Cl, and then we have a solid. So since it's a solid, it stays together. The only time it breaks apart is if it's AQ.
Mm.
Plus AQ. And I'm gonna slide this over so that we can read everything.
So you
Plus.
said when they're all AQ, that means they're all spectators. But what if it's like all like solid, all liquid? Like would that also count?
Yeah, so but then that would count because you then in that case you have no spectators if they're all solids and liquids. There's no spectators.
Oh no,
Everybody-
because of the ions.
But then so how do you know they're all spectators?
So we know that these guys, anytime that you have well, over here, sorry, AQ, AQ, they're spectators. Okay, meaning that they're not going to bond with anything because the only time that they bond with something is that they form a solid, liquid, or a gas. So in this case, chlorine and silver bonded together to form a solid, right? So those guys aren't spectators. So then we determine our spectators because they look exactly the same on both sides. So in this case, if we look at our silver and our chloride, well, they come together over here. So they're not exactly the same. Which are exactly the same on both sides of the reactions when they're in
Nitrogen
there.
and sodium.
The sodium
The sodium ion, okay.
and the
And, and what else?
The nitrate.
And the nitrate. That's right. Okay.
So those
Now,
aren't spectators.
so no, these guys are
Oh, no,
spectators.
they are spectators. Yeah.
Spectators basically means it's kind of like I like to explain it as if a person goes to a party with someone and they just sit on the wall and they don't hook up with anybody, they don't talk to anybody, they're spectators, right? So they're always going to be spectators when they don't do anything, right? So since these guys really all they did, their job was to bring the other guy to the party, right? So nitrate brought silver to the party, and sodium brought chloride to the party. That's all they did. That's it. So those are spectators. Okay, does that make sense?
Yes.
Yeah, that makes a lot more sense. Thank you.
Okay. Okay. Let's see. This one is always a tricky one.
So like the spectators are like loners. They don't bond.
That's right. That's
Okay.
right. Spectators are loners. They don't bond. That's a good way. I'll remember that one. I'm
Wait,
still
Dr. Henry.
yes.
So what would that be? What would be the answer to that one? On like on the options we have there.
Let me see.
All
For-
the ions.
For which one here?
No,
Or
no,
the
no,
one
no.
that-
For the
The
example.
one, the one that I gave you?
Yeah, like what would be the answer if that was the question?
If this was the question, the answers would be it was sodium and so it would be Na plus and NO3 minus. So these would be our spectators.
Okay.
Okay. So in this case, we know that they all would be spectators.
Yeah.
Okay.
So what's cation and anioid?
Positive and negative.
Yes. A
Ah.
cation is positive. Cation. cation, meow, cation is positive, anion is negative.
Okay.
Good? Okay, so let's see. 12, oh, did we do the right one? Wrong one. Oh, yeah. 12.098 grams of A2 reacts with 96.0 grams of B2 to form 108.09 grams of A2B. What is the ratio of the molar masses of A to the ratio of the molar mass of B?
This is kind of like that other one.
Yeah, actually, it is sort of like that other one.
Oh,
Right.
because it's like with the ratio.
Yep. So, because sort of like what we did with percent mass composition.
Mm.
So, if we have 12.02, 9 grams, and that's going to be of A2. And this is going to be the mass of the total compound, right? So we want the ratio of our mass, our molar mass of A to compare to our molar mass of B. So how would I go about doing that? What do you guys think? So if our total compound is called AB, that's right, I'm sorry, A2B, right? That's going to be our total. So, and we know that altogether, this guy is 108.09. Our A, right? So, and this is grams. And then our A, because here we have two A's,
Oh,
right? So then that's going to be basically 12.09 grams, right? So that's going to represent all of our A's, right?
Then we multiply that by 100.
Okay. And then you can multiply that times 100. Yeah, we could do that, right? So we could do that. And so then that would give us our A, right? That would give us our total A compared to everything, right? So that would represent our total A, or our percent of A. Okay. So then if we have for our B, that one would be 96.02. But in this case,
mm-hmm.
we only want half of that, right?
Oh, yeah.
Okay. So it's going to be 1/2 of that. Okay. So if we go 1/2 of that, that would be what?
48.01.
48.01. Okay,
Where do we get the 0.02 from?
Yeah, it's supposed to be a 0, I think.
On B2.
Yeah, 96.00,
Uh-huh. 2
not
0.
02.
oh, sorry, my bad, thank you.
It would just be 48 then.
Yeah, okay, thank you.
All right.
Okay, so we're left with 48, right?
Mm-hmm.
Okay, now, but here, in this case, that would be our ratio of what we're having, right? So our molar mass, so our molar mass would be 1/2 of that as well, right? Because we want just because right now this is for A2, right? Percent A2 to A. So we basically have, what is it, 12 divided by 48?
Oh.
Where did you get
Or that
48
ratio, sorry.
from?
So it would be clear. So sorry. I'm making this harder than what I need to make it. Let me get my eraser. So if we have, sorry, 12 divided by our 96, and then we have to divide it by another 2, right? So what is 12 divided by 96? I mean, 96, since it's a fraction. 96 divided by 12 is 8, right? Is that true?
Yes.
Okay. So then, in other words, right now we have 1/8. Now, since there's 2 of these guys and we only want 1 of those guys, so we have to take another half. So we multiply that times a half. So then that would be 1/16. So then for every 1A we have a 16 ratio. So it's 1/16 ratio. Does
Oh,
that make sense?
yeah.
There you go. Okay.
Where did you get the 48 from?
So initially we got the 48 because if we do that math, let's see, it would be, we would have less, that 96 would be less than what we have. So that would be our 1/8. So I made it harder than what I needed to and clarify that. So what I could have just done is taken those original values, taking this being 12, taking this being 96. But we know that this guy is always going to be 2-to-1 ratio. So we have to divide the final answer by 2 as well. So if we go 12 over 96, that's going to equal 1/8. But we have a ratio of 1-to-2 in our molecule. So that basically means that we need to divide that again by a half. So then you get 1/16. Because for every 2 molecules of A we only have 1 of A. I mean, 1 of B, sorry. For every 2, we have 1 of B. Does that make sense?
Because you divided 1209 with 108.09, so wouldn't you just do the same thing, like 96.00 divided by 108.09?
Yeah, but then we divide them by each other because we want the mass. We want the mass, the molar mass of each one of these, right? So this would give us our ratio of our molar mass to our compound, right? But really, all we're doing is you're going to say your molar mass, you're going to do your percent of A divided by your percent of B, right? And so the thing is that we know that the ratio is always going to be a 2-to-1, right? So we need to also put in another half. Because this guy only has one, where we're going to always have two of that compound, right? So, but then that allows us to get rid of worrying about the 108, because it's 12.09 divided by 108. And then the other guy would be 96.09. I mean, 96 divided by that 108.09. But we're also dividing it by 2.
2.
Because we only have, because this is B2, right? And we only need B. We don't need the full thing.
We only
Is
need
that-
one. Half
That's
of it.
right. So we could have gotten away with just taking this number, dividing it by this number, and multiplying it by half. Because we only need one B. So it's two different ways. This would be the longer way of doing it, right? The way that we're doing it here. What we did, we could just take it, this guy divided by that guy, and remember, multiply it by 1/2. Because that ratio of 2 to 1. So you're assuming that this is a 2, and now by us dividing it by half, that makes our B.
The 1.
Yeah.
I was gonna tell you that at first, but I go, maybe I'm doing it wrong.
No, you're right. Old age,
Wait.
Oops, sorry.
Dr. Henry,
Yep.
with the longer method, right? 96 divided by 2, so like 48 divided by 108.09. That, and then you multiply it by 100, that gets you 44. What do you do with that if you were to do it that way?
Yeah, but you get this number, and you get this number down here. But you have to remember, with your number down here, your 96, you're also multiplying it by 100. You're going to end up, can you hear me?
Yeah, I can hear you.
Yeah, we can.
You're going to end up with the same, ratio, essentially, right? But we've added more work to it by using the percentages rather than just taking these numbers and dividing them by themselves. Does
But
that make sense?
I guess, but with that ratio, I got a 1 of 4. Because 12 divided by 108, then multiplied by 100, got like 11%, or
Yeah.
11.
That's
Okay.
11. Yeah.
It was 11 for the top one, and then the bottom one was like 44. So that'd be a 1 to 4 ratio.
Okay. So let me see if I can explain it the right way. I understand what you're saying. Okay, so since I divided by 48, this would be a 1 to 4 ratio right here, right?
Yes.
And that would assume that we had half the amount. We only needed half the amount for 108. Yeah, so that would be a 1 to 4 ratio. Okay, let me think about it. I know it's 1 to 16. 2.
Then you have to take half of that again.
So let's see. That would give me my B. Yeah, and then
That's 8.
we need that 1/2. So B.
Uh,
2. So it should be divided by
would
2.
you multiply by 2?
No, it would still be divided by 2 in this case. You're saying here, multiply this guy by 2?
No, I'm talking about in the A. Like 12.09
That's
times
right.
2.
It results in 22.
Repeat that one more time.
Like the 12.09, why don't you multiply that by 2 because there's 2 A's?
So yeah, so this would be 2.
You know what I
So
mean?
yeah, I understand what you're saying.
Oh,
So
no.
you're saying, but we wouldn't multiply it
no,
by
no.
2. It
No.
should be,
Because that's already what it is, huh?
Yeah, so
The
it's
12.49,
this amount, and we know that that's gonna be a two.
Yeah.
Right? So we should leave the 12 as is,
Yeah.
okay? And then,
No.
so 96.00, and that is a 1-to-2 ratio. So then you're saying that half of that amount,
It's 48.
but it's also, we're making the assumption that it all reacts, right?
Mm-hmm.
So we're making the assumption that it reacts. But okay, you're right. So we shouldn't be, in this case, dividing it by 2. What we should be doing is we should be multiplying it by 2. So, because, let me make sure if I can explain this right. We know that we need the entire thing to react, right? And for us to account for that ratio, for this being 1-to-2, and this makes, we know that we're using the whole thing because it says we're going to end up with 108.08. So it's just the sum of everything. So everything is being used up, right? So let's see if I can do it another way. Okay, so we're saying so a squared plus b squared yields okay. So then that means that this guy is going to be a half, right? For it to work out. Is that true?
Yeah.
Oh, yeah.
Okay, or we could say 2, 1, 2. Okay, let's do that to make it simple. 2, 1, 2. Okay, so we know that the molar mass of A so let's go, we'll call it M for molar mass of A. And then we have M molar mass of B. Okay, so if we go through this process, we know from based upon our chemical equation that if we're given 12 grams of MB, oh, sorry,
MA.
12 grams of A2, sorry,
Oh,
my head is not working, right? 12 grams of A2. Now, we're talking about its molar mass, right, of A. Now we know the molar mass of A is going to be different than, this is 12 grams of A2. So we're going to divide this number by that molar mass,
times 2.
yeah, times 2, because it's 2 molar mass of A. Okay. And then we're going to take that, and then that's going to form, that's going to give us our number of moles, right? Because then this will be grams, that would be moles, right? of A. And this is just A only. Does that make sense? So, because we know molar mass is going to be mass grams per mole of A,
Oh,
right?
yeah.
That's
Mhm.
so
So that
grams
MA
per
is
mole.
the A2 in the question.
What was that?
That 2MA at the bottom is the A2. Like in
Well,
the
no, because you're dividing it by its molar mass. So that's a combination. This here represents molar mass, right? Okay, and that is defined as grams per mole. And so that would give me my moles of A. Or I'm sorry, that would give us my moles of A2. That's what I would get at the end of the day, right? If I'm dividing it by the moles, so that would be, I'm sorry, yeah, moles of A2. That's what I'm getting at the end. So, but I'm dividing it by this value. And so at the end of this, I get moles of A2. Okay. Now, the thing is that for every 2 moles of A2, so then I have 2 moles of A2, I'm going to end up with 2 moles of A2B,
To
right?
Mhm.
So now we multiply it for us to get, because this represents our molar mass of A, we have to multiply it by 2 so that we end up with A2. Okay, so that's 1, 2 that we're going to be dividing by. Okay, so then you're right. Instead of multiplying it, we should divide that by, so then that would be 6 something, right? So then that would give me, okay, so then that means that for a 1-to-1 ratio of this guy, we're going to have half of that value. So that would be 6.09 grams. Okay, and that would represent our A, that mole ratio for A. Now, if we do the same thing for B, right? So hold on to this number. Somebody put that in our back pocket. So do the same thing for B, then we'd have 96.006 grams of B squared, B2, right? Or, okay, sorry. I keep doing that. I want to put other numbers there. Okay, so then we're dividing it by, in this case, we have for every, so we don't, it would be 2
B.
molar mass of B. Okay, so then same process, this will be B2, and then we end up with that ratio of this to this, so it would be 1, is it 2 to 1? Or is it? Yep, 2 to 1. For every 2 moles of this guy, we'd get 1 mole. Oh, no, sorry, 1 to 2 moles. Okay, so then in this case, we'd end up with, is it 96 point, because these are going to cancel out. This 2 is going to cancel out. That's going to cancel out. 0 grams. Okay, so if we do, what is, so 6, 96 divided by 6,
16.
16. Okay,
Oh,
so for every 1 to 16 ratio, because these are going to cancel each other out here. This one is going to be divided by 2. This cancels each other out there. So that is going to be 1/6. So all we would have had to done was take that ratio and divide it by 1/2. So I screwed up here, but this would be the way of showing how to do it the long way. Okay, so where are we at? Question number 5. So list the number of atoms in each of the, list the number of atoms of each element in the formula unit of ammonium sulfate. What is the chemical formula for ammonium sulfate?
NH4S.
NH4. Oh, let me go.
Oh, wait. Not S. It's something else. It's polyatomic.
Is it NH4 2SO4?
Okay.
SO4.
So it's NH4, and you said parentheses, I'm
Mm-hmm.
assuming, 2
Yeah. 2 SO.
SO4. That's right. That's correct. Okay. How many nitrogens? How many nitrogens?
Oh,
2.
2. Okay, so we can get rid of these first 2, and we can get rid of this last one, right? Okay. So we got 2. How many hydrogens?
8.
8. So that gets rid of the second one, and we have our answer. Okay.
Why is there a 2 outside of the parentheses of the NH4?
Because we know that ammonium is NH4 plus, and sulfate is SO4 2 minus. So then I need how many ammoniums to balance out my sulfates?
2.
Okay.
I'll need 2. That's right. Okay. Okay. Question number 6. How many atoms are in 0.188 moles of sodium? What do I need to multiply that by?
Avogadro's number.
I need to multiply that by Avogadro's number.
I remember that 6.022 times 10 by the power 23.
That's right.
And underneath that would be 1 something.
1 mole
Yeah, 1 mole.
sodium, and this would be molecules, or no, atoms. Of sodium.
Oh man. How much is it?
Okay, what did you guys get?
Let's see. We got 3 numbers, so it's 1.13 times 10 to the power 23.
Okay. That's correct. Number 7. Number 7. It says a coolant widely used in automobile engines is 38.7% carbon, 9.7% hydrogen, and 51.6% oxygen. calculate the empirical formula of the compound. Okay, so what do you guys think we're going to do?
Um,
So let me give you a hint. This is going to be percent mass.
we get the mass number from the periodic table.
And multiply.
That's right. So we're going to get our atomic mass or our atomic mass from the periodic table. And you're right. Are we going to multiply or we're going to divide? Because what are we going to make the assumption is about this guy? So this all represents 100%, right?
100.
Yeah.
Yeah.
Right.
We're gonna-
So let's make an assumption. So if this represents 100% of our coolant, then how many grams? Let's say if we had 100 grams, how many grams would be carbon?
About 38.
38.7, right? It would be that percentage, right? So then let's just assume that we have 38.7 grams, okay, of carbon. So you said divide that by, I believe you guys said the atomic mass. What is the atomic mass of carbon?
12.011.
Okay, 12. Yeah, so we're just going to round to 12, a nice whole number, and make it a little bit easier for ourselves. So then 12 grams of carbon, and that's going to be 1 mole. Okay. Now, somebody do that calculations for me. Get it knocked out of the way.
3.225. So 3.2
3,
or 22.
2, 2. Okay. And that's moles of C. Okay.
And it's 9.7 gram hydrogen.
9.7 grams of hydrogen. That's right.
And then 1 mole. We could just round it to 1.
Yeah, we can just round it to 1.
It's just 9.7 moles H.
Yeah, H. And then 51.6. 1 mole. Oxygen, for oxygen 16?
16. That's right. 16.
51.6. Oh, it's the same, 3.22. Oh, so then would it be like C3H9O3? Or do we have to multiply by something else?
So what do we got to do something first. What did you say?
I don't know.
What should we do? Remember what we need to do?
Oh, are they ratios to each other?
They're going to be ratios to each other, right? So then what should we divide by?
By 3.
By the
'cause
smallest
they'll-
one?
We should divide it by the smallest one. That is correct. So let's go ahead and divide it by, what is the
3.
smallest one? 3.22?
Yeah. Oh, so it's 1. C1.
So,
Well, just C.
Yeah.
No,
yeah.
just,
And then this guy,
let me check. He's gonna be 3.01.
so it's going to be 3 H's.
Mm-hmm.
And then this guy,
It's gonna be 1, so
that should be an O, sorry.
yeah. Oh, CH3O.
But how are they ratios? Like, why are we dividing it by 3.22?
Because when we talk about empirical formulas, it's the simplest form that we can get. So in other words, they're no longer divided by each other. The molecular formula, let's say the molecular formula in this case would be something like this: H9C3H9O3. The empirical formula is just going to be the simplest form that we can get to. So you're dividing it by the number that you can divide it by, right? If it's divisible by a number. Empirical formula is no longer divisible by any other number than 1. So like this guy, right? So this would be the empirical formula of this guy. Okay?
So like you had to find the common factor, huh?
That's right.
Like
And
3.
so it'd be determining a common factor. So the reason why there are ratios of each other, every chemical compound is technically a ratio of each other. Like for instance, if I talk about CO2, well, what is the ratio? How many carbons do I have?
1 to 2.
How many oxygens? To 2, right? So if I have C6H12O6, well, these guys are ratios of each other as well too for this molecular formula. But for what happens in a lot of machines, what they'll do is it gives us the ratio of the elements compared to each other, right? And what you're doing is you're simply doing what the machine would typically do. You're getting the ratios of these compared to each other. So that means that once you get the number of moles, because everything is based upon quantity, and moles is quantity, once you get the number of moles, then you're just comparing the ratio to each other. You're getting one of them so that there'll be 1, and the other one will be relative to that one. And we always want it to be a whole number. We don't want it to be a fraction or a decimal. Does that make sense?
Yes.
Yeah, so you divide it by the smallest component.
That's
so
right.
3.22.
That's right. Because if you divide it by the larger component, then you would get, it'll be, what is it, a third? So this would be 1, and this guy would be 0.33 and 0.33. But we want it in whole numbers, because when we talk about, the quantity of these guys, we know that they have to be whole numbers, because you can't have a half of a carbon atom, or you can't have a third of a hydrogen atom. You know what I'm saying?
Yeah. So instead of like a 3, because we know that it's like divisible by 3, we do a 3.22
because that's the smallest one that we
Yeah.
have, right? You
Yeah.
always want to divide it by the smallest one. Yep. Okay. Okay. So which of the following compounds best explains, which of the following compounds is the best example of a hydrocarbon? Look at the name.
So we need H and a C.
It needs to have an H and a C. Okay, which one here only has an H and C? What about that first one?
No, there's nitrogen in it.
Okay, so we know that one isn't. Okay, what about the next one?
Definitely not.
No, definitely not. What about the third one?
I see a CH.
Is that an H and a C?
Yes.
Yeah.
They're both capitals, right? They're not like lowercase. That's good. Okay, so then that's our gold standard. That's going to be a hydrocarbon. Now, these other components, like this guy is an organic molecule. This guy is an organic molecule. This guy is an organic molecule, and this guy is an organic. Why are they organic molecules?
Because they all have carbon.
Because they all have carbon. Okay. So, what is the formula of the ammonium ion and the hydroxide ion in that order? Ammonium ion. First thing that we should know is that it's a what?
Polyatomic ion.
It's a polyatomic ion. Ion means it has what?
A plus
Charge.
charge.
Okay, so the ammonium is going to have a plus charge.
with NH4. So we can take
Okay.
out the bottom two.
So we can get rid of the bottom two. So then which one is it?
It's the top one because hydroxide ion is OH minus.
Okay. And we have our polyatomic ion sheet to help us with that. So that should be
Yeah, I just
should
had
be
that
like-
open.
that should be an easy question, right? Okay, let's see. Okay. In the complete combustion of C3H8O3, how many moles of carbon dioxide are produced when 23.0 grams of C3H8O3 burns? And we have to put in moles. Okay, what is the first thing I should do?
Find the mass of each element, maybe.
Well, I need to do that. You're right. I'm gonna have to do that. So let's go ahead and do that. But that's probably not the first thing I want to do. We'll
The
go ahead and do that.
equation.
We want our chemical equation, right? So what would be their chemical equation?
C3H8O3 plus O2, yielding CO2 plus water.
Okay, because we know that it's a combustion reaction. It's one of our 5 reactions. That's right.
And it says combustion.
And it's combustion, right? And it says combustion, right? So that's an example of how the equation helps us remember some of those things that we should know, right? Okay. So I need to balance it. Okay, how many carbons do I have?
On the left, we have 3.
And on the right,
Just 1.
okay, how many hydrogens?
8 on the left and 2 on the right.
And how many oxygens?
5 on the left and 3 on the right.
Okay, balanced?
We could put a 3 in front of the CO2 to get our 3 carbon. And then a 4 on the
Okay, so let's slow
H2O.
down. Let's catch up with our
Oh,
numbers. Don't get too far ahead of me.
okay.
Remember, I'm half asleep. Okay, so oxygens are good. And you said for the
A 4 in front of the H2O.
and then that gives me a total of
10.
okay.
So we just need
You put a 2 on the O2. Oh no, a 5.
I don't think we need a 5 in the O2.
No, because there's a 5.
Okay,
We're
let me give you
getting
guys
that
a
5 from somewhere else.
Oh wait, never mind. I see the O3. Yeah, my bad.
okay.
My bad.
So we got
I'm getting
this
ahead of
guy. So
myself,
let's when you have a situation like this,
So we need
and
a
you-
4 and wait, no, not a 4.
okay, we've got to work on that math. So let's do so we have 10 total that we need, right? So 10 minus 3 is what?
That's a 7.
It's a 7. Okay. So then what do we need to put up here for it to balance out? 2 times what will equal 7?
Definitely not a half number.
Well, unfortunately, it's going to be a half number, but then
Oh,
that
no.
means that we have to do what? What are we going to have to do?
Multiply everything by 2.
Multiply everything by 2.
2.
So that would be 2. So we'll say 2 times everything. 2. So then that would be 7. So I'm going to get rid of that. And then that'll be 6. and then that'll be 8. Okay, so then I'm going to rewrite it up in blue. So I can, so 2C3H 8O3 plus 7O2, and that's going to yield 6CO2 plus 8 H2O. Okay, so now we got a balanced chemical equation. What's next?
The mass.
The mass, that's right. So what Josh was saying earlier. Then go ahead, erase this. Give us room to write. Okay, how many carbons do we have?
6.
How many carbons do we have?
Oh wait, oops. There's there's 3 there.
There's 3. We only so
Okay,
we
I
need
was
to, yeah. So remember, we don't use the coefficient. We only use the chemical formula when we start determining its mass, right? Okay, so let's go ahead. We're going to go ahead and we have 3 carbon. So that's going to be 3 times 12.
that's 36.
6.
Looks like I don't know what that is. Okay. How many hydrogens?
8, and it's by 1.
8 times 1. 8. Oxygen.
And then how many oxygens?
3.
Okay.
8 times 16. 48. And then we add them.
Yep.
It's like 94
Close. 92.
or 92.
Very close.
Oops.
Okay. And that's grams per mole. Okay. So then we can go our 23 grams are given. 3.0 grams. And then we're going to divide that by what?
92.
That's right. Sorry, my brain is starting to freeze up here on me. Okay, and so we're dividing it by 92. And we have grams on the bottom, and we have moles on top.
That's 0.25 moles.
Okay. So, but what are we looking for though? Slow down just a minute. Because then we get a little anxious there. What are we looking for?
Oh my God.
We're looking for a different number. I'm trying to think what we're looking for. It's like just a different number.
It says, how many moles of carbon dioxide? So what is that relationship between?
CO.
So what is the relationship between this C3H8O and carbon dioxide? That is the correct answer. So we want to look at our ratio between the two. What is that ratio? Where are we?
3. Are we doing the 3 to 1?
You can say 3 to 1, or you could just keep it as it is to keep it simple for yourself.
2 and 3. I have 2 and 6. No.
2. It's a 2 and what?
6.
2 and 6.
Also said tragedies made life difficult, very
Okay.
difficult for us.
So for every
That's where Endeavor and Shoto come out of the portal. Yes,
Wait, what's the ratio again? 2-6?
Okay. Okay.
Who
I
is
think this
that?
is
Is that a video game? What is that?
that's
For
a
every
YouTube video.
I think it's watching YouTube.
for every 2 moles of C3H8O3, we have 6 moles of carbon dioxide.
Oh, so the coefficient is a mole?
Yeah, you can use it as a mole or you can use it
Okay.
as an atom. It's quantity. It's always a quantity.
Quantity.
Yeah.
Okay.
And as you said, you could have simplified it to a 3-to-1 if you wanted to do that. But it's easier to see it where everything is coming from when you do it this way. So what did you guys get?
0.75.
Okay.
So now we have carbon dioxide in mole,
That's right.
0.75. But there's an extra 0 on the answer.
Because there's 3 significant figures.
Yeah.
I just ran out of room. Okay. Questions?
Oh, so like we're just so you wrote everything, but we're only using like one part. So we're using the 6CO2 and then the
That's right.
2C3H. I see.
Yeah.
I got confused because I was like, wait, we didn't do anything for the H2O or the 7O2.
Because they didn't ask for it, right?
Yeah.
But we could if they asked for it,
Yeah.
or if you just want to do it for kicks and giggles, just for kicks and giggles,
Oh yeah, no, I'm good.
You're good. What do you mean?
Especially
You don't want to do
when it's
extra
timed.
work for nothing?
Well, I mean, when it's timed, you want to like save your
Exactly.
yeah,
Yep.
you want to be efficient.
Exactly. And that's the other thing is that's why it's important to read the question, right? Figure out what they're looking for.
Yes.
Let's see. Which of the following defines the percent yield for a reaction?
I think I remember this. You were telling a story about it. I think it was like actual yield over ideal times 100%.
That's right.
So
That is
how I remember that story was like I and then you max that volume by 100% because you were frustrated about it. So just the A over the I because it says spells out I.
okay.
Like I caramba.
Yeah, okay, I get it. Yeah, that's a good way of remembering it. I'll have to use that one. You guys are giving me a lot of great ideas.
Hi. Oh yeah.
Yeah. Okay. In a general chemistry lab experiment, a student produces 2.73 grams of a compound. She calculated the theoretical yield as 3.40 grams. What is the percent yield? Vicky, you had a question?
Yes, my computer glitched and like it just like paused to number 11 where you circled the answer. So I was like, what did I miss?
Oh, the percent, this one here?
Yes.
Okay. So the answer would be actual yield over ideal yield times 100. And he says he remembers it because AI, I, caramba. So A over the I, and the actual over the ideal.
And then this sounds like a yell, so you max it out by 100%.
Yeah.
Oh, okay, I get it now. Okay. I was confused for a second. Thank you.
You're welcome. Okay. So we're talking about that chem student. Okay, so what am I going to do? Questions are back to back.
Yeah, you basically just use that formula on top.
I just use that formula on top.
Yeah.
Okay. So my actual is what I got in that experiment. So that's going to be my 2.73 grams. And I'm going to divide it by my theoretical or my ideal 3.40 grams. And I'm going to multiply it by 100. And what do you guys get?
9.28% because of 3 significant figs.
Are you sure?
I got 8.
Wait, did I do this wrong? Let me look at the clock. Uh-oh.
Oh no, I think I did it wrong. Hold on.
What did you get?
I had got 8 point something, but I did it wrong. I put 34.0.
Okay.
Times 100. Oh, I got 80. 80.3.
80.3.
Uh-huh. Yeah.
Today's one of those days.
It is.
Yeah, you were preaching to the choir. You were definitely preaching to the choir. I mean, overall, it's going to work out good because you guys are here, right?
Right.
Okay. Calculate the mass of sodium oxide that can be produced by the reaction of 4.00 grams of sodium and 2.00 grams of oxygen in a reaction for sodiums plus O2 yields 2 sodium oxide. What is the first thing that I noticed? Because in most cases, they give us how many givens?
Like 3.
They give us 3.
I don't know. I'm just saying whatever. Calculate the mass of
How many givens do we have here?
2.
We have 2 givens. So anytime that you see that you're given 2 things in most cases, and they're both reactants, that means they're going to be in competition with each other. So that means one is going to be limiting and one is going to be in excess, kind of like our bread and cheese.
Oh yeah.
Okay. So what you're going to do is you're going to calculate, because they want you to calculate the mass of your product, right? So you're going to do it twice. And the one that gives you the lowest value is going to be the right answer. Does that make sense? Because one's limiting. You could only use as much as you actually have, right?
Mhm.
You can't make more. Okay. So if we started off with 4.00 grams of Na, what is the molar mass of, or the atomic mass of sodium?
22.990.
Okay. So that's going to give us moles of sodium. And then if we're trying to calculate, and they want it in grams, how much sodium sodium oxide we're producing. We have to look at that ratio. What is the ratio of sodium to sodium oxide?
4 to 2.
It's 42. So, oops. Sorry, brain is not trying to work today. It's like, nope, I need a break. Okay. And then if we want to get that mass of that sodium oxide, Okay, we have how many sodiums?
46.
Thank you. What's that? 16. Add it together. What is that? 62?
Yep. Times per mole.
Okay, so for every 1 mole,
60.
okay, so
Force.
So 5.39. 5.39 grams.
you said 5.39. Let's see, 6.
Yes.
Okay,
Yeah. 5.39.
Grams Na2O.
okay. And then for oxygen, so
Oh,
16. A ratio of oxygen to our sodium oxide.
1 or 2.
That's right.
Mm.
Oh crap, I almost screwed up. So this should be O2,
Oh,
right?
yeah.
And then this should be 2, and then this should be 32, right?
Anyway. Oh,
Because we know that it's diatomic.
this 2.
Okay. And then you said 2 up here. That's what happens when you're not thinking. Just go through the motions.
Mm.
Let me see what you put it. 0.125. Oops, I forgot the rest of it. Again, going through the motions there.
For the ratio part, how do we know which one to put on top? Because you put 2 mole on top and then 1 mole on the bottom.
You look at what you're looking for, right? At the end of the day, we're looking for the sodium oxide, right? So that's the one that's going to be on top here. And then we're going to get rid of the moles and get to the mass because we want mass of sodium, of that sodium oxide.
I see it now.
Yep. So check my numbers because I'm half asleep.
It's right.
Okay. So we know that they didn't even have the other answer.
Oh, okay.
Okay. We should know this from the very beginning of the semester. For the next question, number 14. When C2H2Cl is burned in oxygen, chlorine gas is produced in addition to carbon dioxide and water vapor. 5,145 kilojoules of heat are released for every 4 moles of C2H5Cl burned. Which of the following correctly represents the thermochemical equation? Okay, so the hint is, there's a couple of hints here. It says released. What does that mean? Is our reaction
So that should be on the
endothermic or
reactant side.
exothermic? What was that?
The
Exo.
kilojoules should be on the reactant side.
Kilojoule should be on the reactant side or on the product side?
I mean product. Sorry, product.
Okay,
Yeah,
product
sorry,
side.
I got it mixed up.
Okay.
I got ahead of myself.
Yep. Okay, so we know that we can get rid of these first, those, right? So none of those are going to be right because they're all on the reactant sides. Okay. Now oh, wait a minute. Hold on. Sorry, I got ahead of myself. I didn't even look at that one. Erase. Except for the third one. Third one possibly could be right. So the first two are wrong. Right? Because these are all on the reactant side. Okay. Now, is the value going to be positive or negative if we write it on the outside? And it's screwed up. It doesn't have the right symbol. Okay. That should be a delta. Okay. So should it be a positive or negative if it's written as delta H equals?
It should be positive because we're like releasing heat, right?
No. So if it's releasing,
We're losing.
we're losing it, right? So it's going away, right? So it's going to be
you
a
have
negative.
to look at it from the inside.
That's right. So it's going to be negative. So we know that this one can't be correct either. Okay. Now, this one, it says for C2H5Cl plus 13O2 yields this. Does that happen? Do we get a yield and a yield?
No.
Okay. So we know that that doesn't work because that's not how you would write in a chemical equation. So our answer is the bottom one. Okay, questions?
So when you're releasing heat, you're losing?
Yeah, it's going to be negative. Yeah.
Okay.
And it's always going to be on the product side when it's negative, and when it's positive, it's going to be on the reactant side.
It's like throwing money in a well. You lost the amount of money you threw in the well.
But you always wish for more money, right? You hope that comes true.
Mm-hmm.
Okay. Which of the following correctly applies to the term solution? Heterogeneous mixture, variable composition, constant properties, dissolved in particles that can be usually larger than 10 to the minus 7th centimeters, exist in a liquid and a gas state.
Heterogeneous mixture?
That is correct.
A solution is always a liquid, right?
Solution, not always. You can have a solution. Well, yes, for yeah, the majority of the time.
Yeah, for
But
most
the
cases.
term solution could also be make mixtures of gases, you know. So, yeah. But we think of it as being a heterogeneous mixture. It's two different things at it, right? Okay, so who was yawning earlier? You're contagious. So you have-
Sorry.
okay, let's see. Convert 337 liters to milliliters, centimeters, and kilometers, or uh, I'm sorry, kiloliters, milliliters, centiliters, and kiloliters.
Milliliter.
So you use dimensional analysis for this one.
Okay, so let's do some dimensional analysis. Okay, so I would look for me, I would look at the one that is different. Well, they're all different from each other. So or except for two of them. And I would solve that question first. If they're all different from each other, like the centis are all different, aren't they?
Mm-hmm.
Centiliters. So I'd solve for the centiliters because then I know which one's the correct one and I don't have to do all the calculations. So then I have 373 liters. So that's an L. So how many for every 1 liter, it would be how many centiliter?
Good.
How many? You said 100. That's right. Because
Yeah.
centi, basically century,
Yes.
100 years, right? So 100 centiliter, CL will equal 1L. So that means that this is going to be 37300 centiliter. Okay, so I can get rid of this first one. I can get rid of the second one. Oh, I believe it is the third one.
Mm-hmm.
Yep, and all the others are wrong. Okay. So saves me time from doing them all. The next one. The temperature in lab is posted as 295 Kelvin. What is the temperature in degrees Celsius?
Isn't that minus 273 and we have Celsius, so it'd be 22.
That is correct. So minus 273.
Where did you get 273 from?
Oh, it's
Because we know,
converting from Kelvin to Celsius.
yep. Because we know when we're trying to convert from Kelvin to Celsius, for degrees Celsius plus 273.15, but you don't have to worry about the 15 because it's, and then that's going to equal Kelvin.
Mm-hmm.
Put that T for temperature. Yes. TC for Celsius and TK for Kelvin. Oh, it's getting bad now. Okay. Can I clear?
Yeah, so you add 273 to the 295.
No, you subtract 273 because we got Kelvin. We have the
Mhm.
temperature in Kelvin
Oh yeah.
and we want Celsius. So it needs to come over to the other
Oh,
side.
okay. So you do the opposite. Okay.
That's right. Yeah, so pay attention to those subscripts. That'll help. And you should have this on your It'll be where the army, the army uh conversions and stuff are at.
Mm.
It'll be on that one. So. Okay, number 18. So which of the following numbers are correctly expressed in exponential? I, is I correct? The first one? See, that's 1, 2,
Looks
3,
like it.
It kind of looks like it.
6,
It's kind of
7.
hard to see.
Yeah.
Oh, it's kind of hard to see. Let me see if I can make it bigger.
Oh, for me at least, because my internet's like really bad right now.
Oh yeah.
Is that better?
Oh, that's really
Yeah.
Oh yeah,
Okay.
way better. Thank you.
You're welcome. Okay, so that's 7. So that one, yes. So we'll put a check by it. It's good. Okay. What about this one?
Wouldn't it have to be -4?
That one's
It should
wrong,
be
it has to
negative 4.
negative.
So that one's
Yeah.
wrong. Okay. What about the next one?
That one should
Quite
be
the
positive.
opposite, +5.
Okay. Should be positive. There we go. So that one's wrong. What about the next one?
Mm.
Yeah, looks like it.
That is correct. So
So 1 and 4. That would be the top one.
there we go. Okay. What is the volume of 22 G of gold, which has a density of 19.3 grams per cubic centimeters?
What are we looking for? What's the volume? Oh,
Volume. Yep.
You use that formula, mass equals density divided by volume, something like that.
we're finding the volume, right?
Mass over volume equals density.
Yeah.
And that's density.
Okay. So then we
Depending on
have
which one
to,
you're looking for. Yeah.
we're
So
looking
we
for
can
volume.
just plug in the numbers.
Yeah.
E equals to M over D? Or no?
That's right. That's right.
Hmm.
Okay. So we have 22 divided by 19.3.
Is 1.14. Oh yeah, 1.1.
Job. Okay, let's see. The nuclear symbol of an isotope of potassium is 41K19. Indicate the number of protons, neutrons, atomic number, mass number of the isotope in that order. Okay.
On to 19.
19 protons. You guys agree with that one? Because that first number represents protons. You guys agree with 19 protons? Is
Yeah.
it 22 protons? Okay, it's 19. So we can get rid of this one. We can get rid of this one.
That one.
And
That
we can get
one.
rid of that one.
It's the
Okay.
top one.
So you said it's the top one?
No, hold on. I'm not even done. I was just guessing. Because
I'm gonna
what's the
just say it's the
number of
top one
neutron?
because the mass
Number
number
of
is
neutrons.
41.
Oh
You
yes.
said the
22.
mass number is 41. That's
Yeah.
right.
Yeah.
Okay.
So
So
that's
then
why
we
we're
can get rid of
separating out.
this one. So
Yeah.
it is the top one. See, good way of looking at it. Found a quick solution. There you go. Okay. So the chemical symbol for germanium is GE. An isotope of this element has, sorry, the isotope of this element has 32 protons, 46 neutrons in the nucleus. What is the nuclear symbol, atomic number, and the mass number of this isotope of germanium?
Oops, excuse me.
No, it's not quite up.
So the atomic number has to be 32 because of 32 protons.
Okay, so we can get rid of
Um,
the
like-
first one, the third one, actually, we can get rid of
no.
That's all of them.
all of them. So it's the last one?
Yeah.
Okay. Good. Because we know the atomic number is the number of protons. That's correct.
Yeah.
Okay. Isotopes of an element may vary in mass because of different numbers of
Protons and neutrons.
because do they change in protons?
No.
No. What do they change in?
I think it's
Neutron.
neutrons.
Electrons.
Neutrons.
No,
Neutrons.
neutrons, 'cause
Neutrons.
neutrons
It's
is
a
mass.
neutral.
Electrons don't have mass.
That's right. Exactly. Electrons are almost massless relative to the other ones. Okay, so we know it's just neutrons.
Okay.
Although if they asked you, the atomic mass is made up of
I think that's what I was thinking.
protons. Yeah, that's right. Okay, let's see. It's the one that always gets me. It says, which of the following is the best explanation of why the mass of an atom is usually expressed in atomic mass units rather than grams?
The first one?
Keep reading.
Hold on. I know I didn't even read them all.
I think it's the fourth one. The mass of an atom and it's in grams is inconveniently small.
Yeah, it's because it's
Oh, yeah.
really tiny.
Oh,
Because
yeah.
it's so tiny.
Yeah. So I did exactly what you did, Juanita. I'm like, I didn't read them all, and then I'm like, oh, maybe this that one. And so my
Yeah.
first instinct is, and then you read that one, you're like, oh, that's the right answer by far.
Yeah.
Okay. Which of the following statements about isotopes is/are correct? They have different masses. They have different number of protons. They have different electrical charges. They have different nuclear symbols. They have different mass numbers. Okay, let's break it down. First one, do you guys think the first one is true?
Isn't 1 and
Isotopes.
5 almost the same thing?
1 and 5?
Yeah.
Yeah. So are they true?
I think all.
I believe so.
Oh,
All
this
are.
is true. This is true. That one is. That one is. Okay. Do they differ in electrical charges, isotopes? So if I have carbon 13 and I
I
have
don't think
carbon
so.
12, are they different in charges? What's changed?
No.
No, they're not.
No, they aren't.
Okay.
No.
So we know that one
Oh, okay.
is wrong. So then it's 1, 2,
2,
4, and
4,
5. Yeah, we're all getting getting a little sleepy now. You can tell because everybody's like,
It's already 10:02.
We'll do this last one and then we'll stop. 'Cause I know you're exhausted and I'm exhausted. It's been a long day, and I have a long day of grading because I'm so behind. People want to graduate. I don't know why. I thought they wanted to be with me forever. So
They can still graduate according to the rules. They can
Yep.
still participate in the ceremony.
how many water molecules are associated with the formula unit of anhydrous cobalt? I can't even talk today. Anhydrous cobalt perchlorate in CO parentheses ClO4 close parentheses 2 dot 6 H2O
6.
6. You're like, God, that's a good way to end with an easy question, right?
I know. So let's go to a more difficult one.
Let's see. Well, let's see if there's a really hard one. You guys look. Is that one? That
Oh, I
was,
think that one's really hard.
you think this one is really hard?
It is a formula called. Let's go to 27.
27.
Oh.
Oh, we could go back if you really think that one was really hard. The 26.
Okay. 26. So we know, what do we know? How many?
Cobalt
How
has
many?
there's 6 hydrates.
Okay, so we know we have 6 waters. So they all seem to have 6 waters. But is this the way we write it?
No,
No. So
we need
can
the
get rid of that.
dot.
We
No.
can get rid of that one. So we need the dot.
Mhm.
Okay. Okay, what else?
Our
What is
cobalt
symbol
has a
for
2
cobalt?
charge. CO.
Those last two,
CO.
no.
You can get rid of the bottom one.
I
Yeah.
get rid of the bottom one. Can I get rid of
The
both of
middle
those?
one.
Because
Oh yeah, we got the really hard one.
yeah. And again, this is where most students make mistakes. They're not paying attention. CB, CB is it cobalt, right? Or
Yeah.
C.
Mm-mm.
So we'll say 27 because somebody asked for 27. See, now they're getting real easy here.
I
So what is
know.
the formulas of let me try again. What are the formulas of the compounds cobalt 3 sulfate and magnesium 2 hydroxide?
So CO, SO4,
So we
3.
know cobalt's gonna be a 3 and sulfate's gonna be a 2, so we're gonna have to balance that out. So we're at least gonna get a 2-3 coefficient.
Okay, so that's right. We can do that cross multiply, right?
So we're gonna take out the second and the fourth and the last one.
And that's SO4. Let me write this down so everybody else can see. Oops.
Okay. 4, 2,
Okay, so then we're
close
switching those. Yeah, swapping them. Yep. So we know we need a 2 here, so we can get rid of this one. We'll get rid of that one. And then we need a 3 here, so we can get rid of this one. And we can get rid of that one, right? So
Mhm.
then we have these 2 choices now. What's wrong with this? Is that hydroxide or is that something else?
Maybe something else.
That's something else because hydroxide would have the parentheses.
That's
Parentheses.
right. We need the parentheses. That's right. So it would be
And manganese is Mn because magnesium is Mg.
that's right. Yep. So there were 2 things wrong with that one, huh? Okay. Not
Okay.
bad. Okay. Yeah, all the other ones are pretty much things that you guys will be good with.
Okay.
If you have any questions, you know where to find me.
And the tutors are covering this too.
They will be. I'll contact them to let them know.